Alrighty, before I get started on 6.2, I want to really quickly go over some things about your periodic table project. I will get your edits back today by 5 p.m. The edits will be in the form of comments on Google Classroom. If you follow my directions, if I ask you for something else, for example, if I say, you didn't answer this part, or you didn't do this correctly, you need to redo it, you need to get those things back to me by midnight tonight. So any edits that I've asked you to do on your part 2 must be resubmitted by midnight tonight. If they're not, I'm not editing it any further, and whatever you hand in will be how I grade it. Okay, your final draft will be due on Friday, also at midnight. And really quickly, this project could change your grade by this much. I just plugged in for some of you, just seeing on RenWeb, what your grades could look like if you got 50 out of 50 on this project. 50 out of 50, it would be 75 out of 75, because part 1 and part 2 were worth 10 and 15 points. So if you didn't follow directions on part 1, if you got 5 out of 10 on part 1, you're already at a 70 out of 75 is the highest you can get. There we go. So just in case it's difficult to follow what I'm saying. Part 1 is out of 10 points, was out of 10 points. That's already been graded. Part 2 will be graded by 5 p.m. today. That's out of 15 points. And your final draft is out of 50. So total, this is out of 75 points. And if you get 75 out of 75, or if you get a high grade on this project, I just plugged it in for some of you. Someone who has a 70% C- right now could go up to an 80% B-. That's a big change. And this is literally just following directions, reading my comments, which leads me to my next point, which is that something as simple as following directions is actually quite hard for a lot of you. This is what was due yesterday. This is the assignment that was posted on Google Classroom. I told you in the directions on Google Classroom that first you needed to read and review my comments that I left on part 1 from Wednesday. Redo it if you had to redo it. If I asked you to redo it, you knew who you were. And then the second part says complete part 2 of the periodic table project, and it says the document and directions are below. This is the document, this is the directions. Most of you, so far, from what I've seen, the people that have handed it in so far, have only done this, and for a lot of them, you mostly only did this. That's pretty much what everyone did. Not everyone. There were some people that can follow directions, so good job. You forgot this part, and you forgot this part. So that's 1/3 of the assignment that you did. So that's going to hurt your grade out of the 15 points. So if I gave you a chance to redo this section of the assignment, or this assignment, then you should redo that by midnight tonight to avoid getting potentially minus 15 points or minus 10 points or whatever it was. All right. And finally, you need to read my comments and you need to listen to my suggestions. If you want to get a good grade and potentially have your grade go up an entire letter grade, you must read what I say and you need to listen to the suggestions that I make. All right? If I tell you, that doesn't make any sense, I don't think you should do it that way, but maybe you could think of the way like this, blah, blah, blah. If I'm giving you a suggestion that is that just so nice, thank you, Ms. Montgomery, for these wonderful suggestions. If I give you this suggestion on a golden platter of how to get an A on this project and you ignore me, do you think that I'm going to grade you nicely? The answer to that question is no. I'm going to be very brutal when I'm grading you if you just blatantly disregard what I'm spending time giving you feedback on. I'm going to step off my soapbox now, and we can go on to part 6.2. If this was too much information for you, there is a brief summary of everything I just said. Redo due tonight by midnight. Final draft due by Friday. Follow directions, you ding-a-lings. All right, moving on. All right, 6.2, we are going to be looking at all of the ways that we can classify the elements. So I really forgot how much I don't like this part of this chapter in general. I like 6.3, but 6.1 and 6.2 are, 6.1 is okay. Really, it's just 6.2. So I'm going to be giving you a lot of information that is from the book, but it's in a simpler kind of a simplified way. And you need to remember my way that I'm telling you, because that's how I'm going to grade you. So AKA, you need to take really good notes and pay really close attention to this next 30 minutes or however long it's going to take to explain 6.2 to you. Because if you just depend on the book, you're going to get answers probably not correct. Please take notes. If you're not taking notes, you will not get participation points for today. You will have to show your notes to Miss Eno at the end of the class. So make sure you're taking really good notes, please, or at the end of the lecture. So let's recall a couple things here. Just because I think this is important, not only after looking at some of your periodic tables, but also because it will help us understand this section a little bit better. We have all of these different components on a tile, which is one of these, on the tile that represents each element. In each element square, there's many components. This one's easy, that's the symbol. This one's easy, that's the name. The other two pieces of information that are on every periodic table, well, any good periodic table, is this number here and this number here. And since you've been doing this project, you know that this is the atomic number at the top. Remember that the atomic number tells us the number of protons in the element. It tells us the number of protons, and since we are only dealing so far with neutral elements, neutral meaning no charge, remember that it also tells us the number of electrons in a neutral element. For example, in aluminum here, we have 13 protons. And since aluminum is neutral, I'm not telling you it's a positive or a negative aluminum. It's a neutral aluminum. If I don't say one way or the other, assume that it's neutral. I'll tell you when we start getting into negatives and positives. This is a neutral atom of aluminum, so it has 13 protons, 13 electrons. We already know that. This one is the atomic mass. And technically, this is the relative abundance of the atomic mass, but remember the atomic mass tells us the number of protons plus the number of neutrons. Well, on the periodic table, it's not a whole number, but we could also have aluminum 26, or we could have aluminum 28, etc., etc. Remember, we have all these different, this word is isotopes of aluminum. So, brief reminder of all of that information. This is chemistry, so you can't just dump that out of your mind. So that's just a brief refreshment there. Let's also recall, since some of you don't know what a period in a group is, based on your assignment, the assignments that I've seen, you also need a little bit of a refresher on this, even though we think we just refreshed you. But anyway, so I don't know why germanium that's not supposed to be, I think I just must have had my mouse on it when I took the screenshot. Remember that the periods are the rows like this, etc., etc. You get the point. And there are 7. Here we have the principal energy levels. There are 7 principal energy levels, and there are 7 periods on the periodic table. It's a beautiful, beautiful combination there. Those are the periods. Remember that this way, the columns are the groups. And you'll also remember, we haven't really talked about what the groups mean yet. We just know that they're grouped together based on similar characteristics. Well, we're going to talk specifically about what those similar characteristics are in 6.2 and 6.3. So the groups, remember we have the 1A, 2A, and then it skips way over here to 3A, 4A, etc. So those are all of our A groups. That's going to be an important thing to remember as well. And we haven't really talked about it yet, but we're going to I have told you that all of these groups here, that is a hard pen to see. Let's use yellow actually. All of these groups here, I've told you, I think very briefly, I said those are called the B groups, and that's all I've told you so far. So you know about the A groups, 1A through 8A. You should have kind of a good understanding of that. And all of these in the middle, I've told you before, are the B groups. We haven't really talked about what these down here are, but today, don't worry, we shall. All right, so just refreshing you, when I say group 1A, this is the group I'm talking about. When I say group 8A, here I'm talking about, whoops, just this guy. The noble gases, remember? When I talk about the B groups, I'm talking about the ones in the middle. Okay, so now let's get a little more into how we classify all of these elements. There's one more thing I forgot to tell you, that this is actually new information that I have not told you before, but I want to look at this periodic table because just like in your book, this is just a different, I guess it's just a different periodic table, but it has the same idea as the one in your book. So we have this, if you look at some of the names or the symbols of the elements, for example, if you look here at hydrogen, or if you look here, this one's kind of hard to see actually. Yeah, hydrogen, let's just look at these ones. And we'll look at mercury, and who's the other, bromine. So you see how hydrogen is written in red, right? Whereas sodium is written in this gray color. And mercury down here, number 80, mercury is written in blue. So this idea, this thing that we see, that some of them are written in gray, some of them are written in red, and some of them are written in blue, this tells us about the state of the element. And what I mean, remember that states, we have 3 states of matter. So at room temperature, this is very important, at room temperature, we have hydrogen in red. Hydrogen is a gas at room temperature because it's written in red on the periodic table. Mercury, down here, is a liquid at room temperature. And you'll see here is our key. Blue means liquid. And gray, or no color, white, whatever you want to call that, means solid. Okay? So this is the same concept that you should have read about in your reading of 6.2, the same colors, but let's look now at the periodic table that's in your book, because that's the one I'm going to be using for the quiz. Alrighty, here we go. So, same thing. We have hydrogen in red. These ones in black now, but we have a key, so we can look at our key and determine what each one means. And blue, we have a liquid, and then we have this written in gray. So all of these ones down here. So this is what you're going to this I will not give you on the quiz. I won't give you this key. So you'll need to know that black means that at room temperature, this element, vanadium, is a solid. At room temperature, because oxygen is written in red, that means that it is a gas. Because mercury is written in blue, at room temperature, it's a liquid. And all of these ones, I don't even know, hassium, let's talk about that one. This is written in gray. That means that it's not found in nature. So what that means is that all of these gray ones, were actually only synthesized in a lab. We don't find, and these ones down here too, promethium, we don't find that in nature. We're not going to find it in rocks or in salt mines, for example. We're not going to find any of these gray ones in nature. We can only make them in a lab, but we can make them, so they are an element. The difference is between the gray ones and all the rest, whether they're any of these 3 other colors, is that we can find all of these other ones in nature. If we look in the right spot, if we mine, if we whatever have you, we can find those in nature, but we cannot find these gray ones in nature. So you're responsible for this right here. And this is directly from your book. You need to know this. and it will not be given to you on the quiz. You need to know that black means solid at room temp. I'm going to say at room temp, but that's really only for, I mean, that obviously doesn't include the gray one, right? It's at room temperature, we can't find this in nature. No, we can't find it in nature anywhere. But for the other three, the states of matter, we can find those in nature at room temperature in that state of matter. All right. So there's a question on your assignment that's due today that kind of lays all of that out, and you'll be able to hopefully use this to answer that question. All right, so that's the last thing I wanted to say about like how we read the periodic table, reminding you of how we read the periodic table. So now we're going to move on to the 3 different ways that we're going to classify things. So we have lots of different ways that we can organize and classify our elements. The first way we've actually already talked about. This is classes. We have 3 different classes of elements. You'll remember that we have these 3 main classes. We said we have metals, metalloids, and non-metals. And remember, we talked about all the different characteristics of those metals, non-metals, and metalloids. And so that's the first way. I'm not going to go in depth with that information again. So that's the first way. We have classes. These are the 3 classes. The second way that we can organize is by what I'm going to call regions. Your book does not call it this, and it explains it in a slightly, the information is still the same, but it's explained in a more complex way that you don't need to know for your quiz in the book. So I want you to understand what I'm saying and take notes on this important part. So we have 3 different regions that we're going to look at here. The first one is are the representative elements. Then we're going to look at the transition metals and the inner transition metals. And before I go any further, the representative elements, are basically all of the group A elements. And actually in your book, when it talks about representative elements, it says only groups A 1 through 7, but in real chemistry, the representative elements are groups A, 1A through AA. So all of these plus all of these are the representative elements. They're all the A groups, which we already learned about. We've talked about that before. All of the transition metals are the B groups. That's all of these guys here. All right, and then the inner transition metals are these weird randos on the bottom that are actually stuck right here in the periodic table, but we don't actually put them in there because the periodic table would be this much longer if we did that. So, anyway, these are the 3 main regions of the periodic table. We are going to look at the individual groups, like the name of this group, for example, group 1A, the name of this group, etc., the name of the bottom groups next. But they all fall into one of these 3 regions. So I'm going to be talking about the different groups in relation to their region. All right, so we need to talk about the individual groups. And I'm going to do this by talking first about all of the individual groups within the representative elements, so all of the A groups. Then I'll talk about the B group. We don't really break them up into individual groups. We just still call them just the transition metals. Then I'll talk about the 2 individual groups in the inner transition metals. So first, let's look at the individual A groups, because that's where we have the most diversity. And if you look here is everything I am going to be talking about right there. So our first group is our 1A group. Our 1A group, from your reading, you should remember that our 1A group are also called the alkali metals. Or I guess is also called the alkali metals. So 1A, where can I write this? I'll write it down here. So group 1A one. Dang it. All right. Group 1A is our alkali metals. That's the name of the first group. So here we have our A name, our 1A group, and then this is the common name, is the alkali metals. The second group, group 2A here, these are called the alkaline earth metals. Alkaline, earth metals. Then we move on over to group 3A. Group 3A through group 6A, they don't have a common name. We just call them group 3A, 4A, 5A, 6A. Some people might say the carbon series or the nitrogen series, but I don't care about that. I'm not going to call them that. I'll just say group 3A. So this one has a special name. This one has a special name. All those in the rectangle there do not have a special name. Group 7A has a special name, and I think we've kind of already talked about this. Group 7A is the halogens. They're the halogens. And then finally, group 8A, we definitely talked about this one. They also have a special name. Their special name is the noble gases. They are the noble gases. All right, so all of these are the 4 groups of representative elements that you need to know the common name of. All right. Okay. Then we have our middle group here, our B groups. That's all of these kind of lighter yellow ones. We have all of these B groups. These B groups, they don't have individual names. Like group 3B doesn't have an individual name, but all of the groups together are just referred to as the B groups, but they're also referred to as the transition metals. Same thing as their region. So the transition metals, B groups, they don't really have a special individual name. Transition metals. But our inner transition metals, these at the bottom here, they do have a special name. 2 special names. So if you look very closely at the first 2 elements of these series, these rows of elements, if you look here, we have lanthanum and we have actinium. So what these two, both of these rows make up the inner transition metals. And we have this one and this one, and they have 2 different names. The top row is called the lanthanide series, and the bottom row is called the actinide series. And if you cannot remember what the series name is, you just look at the name right here, lanthanum, of the first element, and you say lanthanum, oh right, the lanthanide series. Or if you can't remember the bottom one, you look at the name of the first element, which is actinium, and you remember, oh right, the actinide series. So they're just named after the first element in that row. So here is kind of a summary of all those things I just said. We have our representative elements, which only groups 1A, 2A, 7A, and 8A have special names. And these are really the only 2 new ones. I think you know halogens and noble gases already. Then we have our transition metals in the middle, our transition elements in the middle, which are also called the transition metals. Those are these here. And then we have our inner transition elements, which are the bottom 2 groups here and here under the bulk of the periodic table, and they're called the lanthanide series and the actinide series. So those are all of the different ways that we can classify these elements on the periodic table. So what you're going to need to be able to do is, I'm going to say, look at silicon on the periodic table, right here, silicon. Silicon, we can classify silicon in several different ways. The first way we could classify it is we could classify it by class, right? Is it a metal, a non-metal, or a metalloid? Well, it's in this little staircase, those 7 special elements of the metalloids. So silicon is, its class would be a metalloid. Let's scoot this over. Metalloid. All right, how else could I classify it? I could classify it by group, by region, right? So, by region, we'll say first. By region. So, it is in the 4A group. So that means that it's a representative element. So, its region would be representative. And more specifically, the specific group that it's in, it doesn't have a common name, but we do call it the 4A group. So there's 3 different ways there that I could classify silicon. I could also ask you, is it a solid, liquid, or gas at room temperature? And because it's written in black here, you know that it is a solid. All right, what about if I asked you about to classify to the best of your ability bromine, number 35 there. Let's classify bromine. So unless you've been doing this for a long time like me, or unless you've memorized where the metals, nonmetals, and metalloids are, in order to answer the class, you might have to refer to this periodic table a couple times before you realize that who's a metal and who's a nonmetal, and where the who's a metal, who's a nonmetal, and where the metalloids kind of exist here in that weird staircase. So if we look at bromine, we can see, bromine is a nonmetal. It's also on the far right of the periodic table, so that's kind of a good indication that it's not a metal. So it's a nonmetal. The region that it's in it's a representative element because it's an A group. Representative. And its specific group would be group 7A, and its common name would be, it's in group 7A, so remember that would be the halogens. So its common name for the group that it's in would be the halogens. Let's do just one more really quick. Let's look at magnesium. Magnesium is right here. So the class that it's in, well, it's on the far left of the periodic table, and it's not hydrogen. Remember, hydrogen's the weirdo, that's the only non-metal on the left side of the periodic table. So it is a metal. The class for magnesium is metal. Its region is it's in an A group, so that means that it's a representative element. Its specific group is group 2A. We just circled that here. Group 2A. And the common name for that specific group is the alkaline earth metals. There we go. So those are all of the ways that I can describe where magnesium is and classify it based on the periodic table. All right, so the last thing we need to look at is electron configurations in each of these groups. And I kind of talked about this when I taught you electron configurations, but we're going to look at the similarities of these groups, or that exist in these groups. So one of the main similarities, the reason that they're grouped the way that they are, is because of their electron configurations, because of the way their electrons exist. The way that their electrons exist gives them the special characteristics that constitutes a group. So let's look at some examples of what I mean here. All right, So here we go. We're going to look, like I said, we're looking at the electron configurations in the groups because the elements are sorted into these different groups because of their electron configurations. So group 1A, we're looking at group 1A here in this picture. It's kind of small, sorry. All right, group 1A. Of course, we're not really going to talk about hydrogen because hydrogen is just the black sheep of the family and we just aren't even going to go there. So let's look at all of the electron configurations in these elements here. All right, here we go. We have I'm not going to do all of them. Actually, I'm not going to do the last two because it's way too long and I won't be able, you'll get the point after this much. So let's look at the highest energy level that has electrons in it. So the highest energy level. So basically, where are the last electrons placed and how many electrons are in that total energy level? In lithium, the highest energy level is 2. It's got 1 electron in it, in the S sublevel. So its outermost electron in the highest energy level is in the 2s. What about for sodium, Na? We look at its electrons. Where are its electrons in the highest energy level? Well, 3 is the highest energy level, and it only has 1 electron in there, in the S sublevel. So its highest energy level, and where its last electron is in 3s1. Then we go down to potassium, and what a shock, 4s1. Then we go down to rubidium, and again, what a shock, we have 5s1. So we see a little bit of a pattern here. Maybe we need to look at our second group, our alkaline earth metals, in order to understand this pattern a little bit more. So if you're still not really seeing what pattern I'm talking about here, with each of these electrons, their final electron being in the same for all of these, basically, in the S1 sublevel. Let's look at the group 2, the alkaline earth metals, and we'll see if it makes more sense there. So if we look at group 2, let's look at the electron configurations for a couple of these guys and see if we can see a pattern there. So again, let's look at the electrons that are in the highest energy level. How many are there in the highest energy level? The highest energy level is 2, and there are 2 electrons in the S sublevel. For magnesium, has its highest energy level is 3, and it has 2 electrons in that sublevel S. For calcium, we are in the 4s2, and for strontium, we have 5s2. So, do you see a pattern now? In the the highest energy level, we have the same number of electrons in group 1A. They all have 1 electron in that highest energy level. In group 2A, they all have 2 electrons in that highest energy level. What do you think the trend is for group 3A, group 4A, group 5A, etc.? You guessed it, group 3A, all of them, they all have 3 electrons in their highest principal energy level. 3 here, 3 here, 3 here, 3 here. So here we look at their highest principal energy level. So this is 2 and this is 2. So we have to count all of those electrons that are in the second energy level because that's the highest energy level. There are 3 there. Same with this one. We have to look at 3s and 3p because the principal energy level is what we care about when we're looking in this situation. So we have 3 electrons in all of those. In group 4a, we have 4 electrons in the outermost energy level when we draw the electron configurations for all of those. So the pattern here is that it would be the same, well, it's the same for the rest of the periodic table. For group 5a, all of the elements have 5 electrons in their highest principal energy level. All of the group 6a group, all of the elements in the 6a group have 6. All of the elements in the 7a have 7. All of the elements in the 8a have 8. So, why does this matter? So what? This matters because these electrons that I'm talking about, that you keep hearing me talk about, the electrons in the highest principal energy levels, these electrons, these four electrons, these five, let's go up here. These three electrons in that outermost, I keep saying outermost energy level, or that highest energy level, the highest principal energy level, these are called valence electrons. Valence electrons are the electrons that react, that cause chemical reactions. They're essentially the electrons that determine how an element behaves. So they're the most important electrons. They're the ones that determine if an atom or an atom of a certain element can bind with another atom. So they're the electrons that give the element their behaviors, their characteristics. All right. Why does that matter? That matters because all of the groups, group 4A, all of the elements in group 4A have 4 valence electrons. So the reason that they're all grouped together is because they have the same number of valence electrons. They all have 4 here. The reason that that matters is because those 4 valence electrons determine how the element is going to act. So all of these in 4A, carbon, silicon, germanium, etc., all of these elements, they are similar because they have 4 valence electrons, because they have 4 electrons in their outermost or highest principal energy level. The reason that group 1 is grouped like that, the reason that we have these groups, specifically group 1 in this example, is because all of these elements have 1 valence electron in their highest principal energy level. Same with group 2. They all have 2 valence electrons. So that's why they all act similar, and that's why they're placed in group 2. So we have groups because, or the reason, the way that we came up with the organization of the periodic table into these groups is because of those valence electrons, because of those elements. We can organize them based on their valence electrons. All right, so there's, in summary down there, the point of the groups. All right, so that, I believe, is all we have for 6.2. There's one more little part that's just, I'll just show you. Well, I'll start with that tomorrow. I think that's enough information for today. So let's go back over everything we talked about today really quick. Remember, we recalled, we were doing some refreshers at the beginning, looking at what each part of the, each element tells us on the periodic table. Then we looked at these 3 colors for different the way that the symbol is represented on the periodic table. The color that it's represented in can tell us a little bit more information about the element. So if an element is written in red, that means that it's a gas at room temperature. If it's blue, it's a liquid. Black, it's a solid. And gray means that it's not found in nature and it's only synthesized in a lab. Then we talked about the many different ways that we have of classifying and organizing the periodic table. So first we talked about our classes, which is basically just from 6.1. We have metals, nonmetals, and metalloids. Then we talked about our regions. We might hear us referring to regions of the periodic table. So we have the representative elements. Those are the group A, 1A through 8A elements. The transition metals, those are the B groups. And the intertransition metals, those are the groups at the bottom. Then we talked a little further about the individual groups, the names of all of the individual groups. That was summarized here for us. Those names, you'll be responsible for knowing all of those names. And then we talked about how we can use, how electron configurations are used to organize the groups. And the main point of this is that the elements are sorted into their different groups because of their electron configurations, but more specifically because of their their valence electrons, how many valence electrons they have. And remember, valence electrons are the outermost electrons. They're the electrons in the highest principal energy level. I'm going to start tomorrow by looking at we only talked about the representative elements. We only looked at those valence electrons in the A groups, right? We only got to 8A. So tomorrow I'm going to talk about how the valence electrons look, or how the electrons in general look in the transition metals and in the inner transition metals. It's a lot simpler than, I'm not going to draw out every single electron or configuration like I did today. I'll start here tomorrow, and we will also look again at the S, P, D, and F blocks that I talked about a little bit when I was talking about electron configurations. That is this picture here. We'll look a little bit more in depth at this picture from your book, and then we're done with section 6.1. So there's only really like 5 minutes left of 6.1, but I'm gonna stop because this is a little bit more information, and I think I've given you enough today. All right, so yes, you can finish the 6.2 questions, and then tomorrow we will move on to 6.3. So I'll finish 6.2 for 5 or 10 minutes and then move on to 6.3. You also will need to do your 6.3 notes for tonight. So you can spend the rest of the time working on those 6.2 part 1 questions. And then tomorrow we'll finish 6.2 and start on 6.3. So your homework is to also do 6.3 notes. Please let me know if you have any questions. That is it. Goodbye.